channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST subject. The name of the full subject is Computer-Based Numerical and Statistical Techniques. This has been the engineering subject, and we have started. This has been the first class of it, and we will start discussing about the computer-based numerical and statistical technique. Where this subject been concluding the four unit here itself, and that has been the important one in terms of engineering as well. So before starting with this, it's a huge request to all the viewers to please go through the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. We'll start with the unit 1 here. Here in the unit 1 is the name of the unit is Computer Arithmetic Errors and Roots of Equation. This is the name of the unit here. So as I told you here itself, that the name of the unit is your Computer Arithmetic Errors and Roots of Equation here. In this we have to discuss we'll just discuss about the question answers that solve problems. We'll discuss about where the important points to be remembered is your floating point algebra, types of error, analysis of estimations of error, numerical your instability, bisection method, second method, regular falsy method of the false position, Newton-Raphson method, iterative or successive approximation method, solutions of polynomial equation using a systematic equation, their short answers, questions, and the concept flowchart we'll be discussing here. So before starting with this, we'll discuss about the that is floating point algebra, where important points to be remembered we'll have to understood about it. We'll go ahead for the same. So first we'll discuss about it, which is your floating point algebra. In floating point algebra, we have to discuss the first, that is being the significant digit. So here we go ahead for the significant digit as well. Significant digit. In case of significant digit here, these are the numbers of digits that can be used with confidence as well. We'll talk about significant digit after decimal point. Significant digit after decimal point. In this, these are the numbers of significant digit after the decimal point. For example, 12.314 has a total 5 significant digit, and their significant digits after decimal point. Accuracy is the closeness of calculated value to the exact value, and precision is the representativeness of the value as well. You can write it down. I just repeat it. Accuracy is the closeness of calculated values of the exact value, and precision is the representatives of the values as well. Here, a floating point number that is being expressed in the form of floating point will be represent floating point, which is being equals to representing x equals to mb of e b power e. Here m is that is the mantissa, which represents the fractional part of the x here, and your b, that is the base of the number system, which is binary, hexagonal, octagonal, decimal, and this e, that is being in the power, it is exponent, which represents the integer part of the x as well. For example, 0.387 into 10 to the power over 2 is the floating point of that. It has a mantissa. So we'll go ahead for the same, and I will just represent it to that as well. So कोई number है आपका, for example it will be 0.387 3875 into 10 to the power 2. So इसमें क्या है? For this what we have here is your 0.3875. This is your mantissa, and exponent is your 2. This is your exponent, and the base of that number, which is, you can see, this has been the 2, base equals to 10 here. That is a decimal number system here. So you have to consider it here. We'll talk about the considering the another number here, which has been like x equals to 24.389 into 10 to the power 2. So here this has been the mantissa, and this has been the exponent. So this number that can be stored in memory, which is 389 e2, that that here e stands for the exponent, and for normalized floating point number, that is, just write it down here itself, the conditions for it. For normalized floating point number, 0.1 is equals to mantissa is less than 1. So that's the exponent is arranged according to, and again, to the above number, where we can represent x equals to 24.389 into 10 to the power 2. So x normalized, where x normalized equals to 0.24389 into 10 to the power 4, or 0.24389 e4 here. So to add or subtract the floating point number, that are follow following step. That is, first we have to normalize the given number, then make their exponent equal by adjusting the decimal point, then perform addition or subtraction of mantissa of the two numbers, and then normalize the result as well. This is the process how you have to perform it, and that we are performing in the following question as well. I repeat, you have to normalize the given number, make their exponents equal by adjusting that decimal point, and perform the addition or subtractions of mantissa of the two numbers, and then normalize the result as well. You go ahead that you have to note that the exponents that are not added or subtracted, then you multiply the two floating point number. Following steps should be followed. Multiply the mantissa of two numbers, add the exponents, and normalize the result. To multiply the two floating number, that following step should be followed. Multiply the mantissa of the two numbers, add the exponent, normalize the results. That will be when you are going to multiply. And to divide two floating number, we perform the following step. You have to divide mantissa of the two number. Exponent of the result is equals to the exponent of the numerator minus exponent of the denominator, and then you have to normalize the result as well. And I just write it down for you all so that you will get to know. Otherwise, you will, if you are new for this, you will not be able to understand. So I will go ahead for this. I hope you will be getting it out, and you can just make notes if you are making it notes, because this is more than a theory. It is a numerical report, as the name suggested you, the computer based numerical and statistical techniques. So it is not that easy to add or subtract following points. Number, we follow following step. So the first we have here for this, you have to normalize the given number. Second we have here, make their exponent equal by adjusting decimal point. Third we have here, which is perform addition or subtraction. Or subtraction of mantissa of the two number, then normalize the result. Now to multiply the two floating point numbers, that following step should be followed. So for the same would be to multiply the two floating point numbers following steps should be followed. So what the followed should be followed here? First we have to multiply the mantissa of two numbers. Second, add the exponents, and third is we have to normalize the result. Then another we have to divide two floating point numbers, we perform the following step. To divide two floating point numbers, we perform following step. First, divide mantissa of the two numbers. Second is exponent of the result equals to exponent of numerator minus exponent of denominator, and then third we have normalize the result here. So the associative and distributive law that are not valid in floating point arithmetic, that we'll discuss here, which is being as follows, and that what we will have to talk about it. So here we go ahead for the same, that is a plus b minus c is not equals to a minus c plus b, and ab minus c is not equals to ab minus bac as well. That what we have to cover up. And there are many questions in terms of it. I think that has been related to more than 80%. We have questions here that has been asked, so we'll deal that with non-distributive floating point or non-associative of floating point as well, with their absolute error and relative error as well. That has been the important one, so we deal that. And it's a huge request when you are going through with the subject that you will make a notes. Of course, that has been important for you because this is a long unit as well, and all these things are important to you to maintain it, and when you go through with that, I hope we'll deal with many of the questions here, and we will discuss many of the questions. I hope that we will discuss that literally we're dealing with the topics here, and with the numerical that has been asked. So it's near about 70 to 80 questions we'll deal in this unit. So we'll go ahead for the further here. In the same cases, now we'll discuss about associative and distributive law that are not valid in floating point arithmetic that we have here. So let's go ahead for the same. Associative and distributive laws are not valid in floating point arithmetic that we have. So we have your that has been a plus b minus c is not equals to a minus c plus b. The second we have ab minus c does not equals to ab minus ac that we have here. Now for the same, we'll go ahead with the question first, and that is the important one here. And that the question we have, you have to add the following floating point numbers. So we'll go ahead for the same. Add the following floating points numbers. So the first number we have here is 0.3879 E7 and 0.813 E7. So here the given floating point number are normalized, so therefore we can add them directly here. So we'll go ahead because they are in the normalized form. So we'll go ahead for the same. That has been 0.3879 E7, and here it is 0.813 E7. Here it is plus, so this has been 1, 1 and 1. It will be 1.2009 E7. So there the exponent of the result is as same as that of the number, and here this has been the only madrasa that are added here. Okay, so here the result should be normalized, and answer will be your. In the same cases we go ahead, and that's what we have to talk about it. And so here the result should be your 0.12009 E8 that we'll have as an answer here. And on the same cases, now we'll go ahead for add the following floating point numbers. We talk about it. So we have here another question for the same. This has been your 723.813 E14 and 89.73 E12 that we have here. So here the first normalize the given number first, that is will get your 723.813 E14, that is being equals to 0.723813 E17 and 89.73 E12 is equals to 0.8973 E14. So then we make an exponent equal, and we will make exponent of second number 217, and that is we will make it 0.8973 E14 is equals to 0.0008973 E17. Now adding the two numbers 0.723813 E17, 0.0008973 E17. Then we'll add it on. That is being your 0.724710 E17. The result is normalized form. I will go ahead for the next number which we have here. That is being the third number. We talk about it. So here we go ahead for the same. Third number we have 100.312 E25 and 81.813 E27. So that for the same we'll go ahead here, and that is being, we have to talk about it. First normalize the two numbers. That is being 100.312 E25 equals to 0.1000312 E28 and 81.813 E27, 0.81813 E29. So here we will make an exponent of the first number to 29, that is your 0.10031 E28 is equals to 0.0100312 E29. Now adding the two numbers, we'll get 0.0100312 E29. Here this is 0.818133 E29, and will be added on. We get 0.828164 E29. That result is normalized, and hence it is the answer as well. So now we'll go ahead for the next question as well. We'll do for that subtract the following floating point as well, and that is being even though important too. And let's go ahead for the same as well. So here we go ahead. Subtract following floating point numbers. So the first number we have here 0.418968 E5 and 0.23818 E5 that we have. We'll solve it. Here both the numbers are normalized, and therefore we can subtract directly. So we'll do it there directly as well. 0.4189628 E5 minus 0.23818. So it will be your 0.18078828 E5 here. So this is an exponent of the result is the same that of the number, and with this we talk about it. So this is being the only mantissa that has subtracted. So the result we have here 0.1807828 E5. This is we have, and it is not, it is normalized. Yeah, we'll talk about another question that what we have here as well. So which is being as follows. Number is 583183 and 78.1671 E19. So first we will normalize the number for 5831.1863 E20, 0.583183 E23, and 78.1671 E19 equals to 0.78 1671 E21. So here we'll make an exponent of the second number is 223. So we'll get 0.781671 E21 equals to 0.0078161 E23. So now subtracting the number here, 0.58318630 E23, 0.007811671 E23. So we'll subtract it, will form 0.57536959 E23, and the result is in the normalized form. That's what we have to talk about it. So now here we're gonna end up with that is what we have to discuss. We'll start discussing about the rest of the question in the next coming class, that is being the important one as well. So here we're gonna end up with computer arithmetic errors and rules of equation, and in the same cases with computer based numericals and statistical techniques. In the same cases, other than CBNST, we had done your sociology, software engineering. We had done your chemistry, where we had done your chemistry, which is being unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, and as well as unit 10 as well. And after that, we had done the conversions, logarithms, antilogs, and we had done your the element symbols with the atomic number and the molar masses, of course. And after talking about that, we had done understanding the human being comprehensively, the human aspiration and its fulfillment, and where we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6 with a 2 marks possible question as well. After talking about that as well, we had done that is we had completed your reasoning. That has been a very important subject in terms of competition wise, and we had done that, and we are dealing with this as well. And reasoning, we had done your verbal reasoning and non-verbal reasoning. In verbal reasoning, we had done your general mental ability and the logic reasoning. In non-verbal reasoning, we had done your series analogy classification, analytical reasoning, method, image, water image, embedded figure, completions of incomplete pattern figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice draw situation, figure formation analysis, and now we had dealing with the practice question paper, which is being the important one for you all to deal with the different types of question paper at once. After talking about that, we are dealing with the ER diagrams. That has been important for you as well. And after talking about that as well, we are dealing with the quantitative aptitude. In quantitative aptitude, we had done your arithmetical ability. We have started with, in that we had done your operations of numbers, LCM and HCF of numbers, decimal fractions, simplification, square roots and cube roots. And then we had done problems on numbers, problems on ages, arts and indices, and percentage we are dealing here. After completing that, we will be surely starting with the next topic as well, and we are going to start with your the 11th second part of the chemistry and 11th first part of physics as well. So very soon we will start with this. In talking about the computer CBNST, we just talk about it. In CBNST, that is this has been the first class here. So just name the following subject, that is computer based numerical and statistical techniques here. In this we have to deal with 4 units, where in unit 1 we had, this has been divided into 2 parts. So that has been the computer arithmetic errors and your roots of equations as well. In computer arithmetic error, we have to discuss about the floating point arithmetic machine, epsilon, round of error, chopping error, truncation error, associative and distributive law in a floating point arithmetic, inherent error, error propagation, numerical instability as well. Roots of equation, that we have to deal with the second method, Newton's Raphson methods, a fixed point iteration method for simple roots, derivations of their rate and conversions, and ethical accelerations of conversion, modified Newton's Raphson method, and multiple roots bridge White method for polynomial, and of course that is your Bairstow method for quadratic factors, and computer algorithm for of these methods as well. In unit 2, we have to cover up the interpolations and curve fitting, In interpolation, we have to cover up the algorithms and the error analysis of the Lagrange and the Newton divided difference interpolation, relationship in various differences operation, piecewise linear interpolation, cubic spline interpolation, natural spline, and Chebyshev's polynomial approximations, Langkos economization of power series. In curve fitting, we have to do it with linear and non-linear least square approximation, and third, conditioning in least square method, gram schematic process of orthogonalization, computer algorithm of least square curve fitting. In unit third, we have to discuss about the differentiation and integration. In differentiation, we have to discuss about the method based on interpolations and finite differences, and Richardson extrapolation, integration, error analysis of the trapezoidal and Simpson methods, Newton's case codes of the integration method as well, and then after that the Gaussian's integration method, Gauss-Legrand method, Lobato integration method, and the Radau integration method, error terms in the integration method as well. In terms of unit 4, we have to cover up the solutions of simultaneous linear algebraic equations, solutions of ordinary differential equation, and statistical technique. In solution of simultaneous linear algebraic equation, we have to cover up the Gauss elimination method, third, and that is your the conditional system and condition number successive over the relaxation method, rate of the conversion. Solution of ordinary differential equation, where we have to cover up the single step method, rungs that second method, third order and the fourth order method, so multi-step method, predicator corrector method. Statistical technique, we have to cover up the statistical hypothesis, test of hypothesis, type 1 and type 2 errors, level of significance test, involving normal distribution as well. So here we're gonna end up with this computer based numerical and statistical order of the first class, and we will surely be start discussing about the second class of this as well. All these are important. You will just make a note of it, and you will get to know all this topic that we are dealing with, all the questions that we are dealing with here. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box, and please like, share and subscribe our channel so that many and maximum people can get the information at once, and then you can also enjoy the video as well. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box.